Welcome to Getting Started with Python for Test Automation. This is our Friday test workshop. I'm going to try and make it more informal, and I would love as much feedback and interaction as we can get on today's topics. We're going to cover data structures. I think we briefly introduced lists and maybe dictionaries previously. Okay. So we're going to cover lists in more detail. We're going to talk about dictionaries, which is a more complex data type, as well as tuples and sets, which are less commonly used data structures, but also have a use. We're going to introduce using functions in Python. Functions are a core feature that allow us to structure our code. And we're going to introduce PyTest. So that's our topic. So let's talk about lists. A list is sometimes called an array, although an array is technically a simpler collection. But it's what it sounds like. It's a list of things, right? In this case, you can see I've got an example list of knights. So going with the Python theme, we're going to talk about Monty Python and the Holy Grail and use that for our examples today, right? So we've got a list of knights. This is our variable name, knights. So knights equals, remember the single equals is an assignment. So we're assigning this list to it. I'll jump into the code and talk a little bit more about lists as well. All right, so I'm going to open IPython. You can also use your favorite code editor to do this. So to create a list, right, you can just do L for list equals and some square brackets, those little characters over the return key. And I have a list, right? So I can type of L is list. And I can assign values to the list, right? I can make 1, 2, 3, 4 in list. Wait, that's wrong. 1, 2, 5. Sure. And then I can see my list, like I can print it out. I've got 1, 2, 5, and I can refer to each element in the list. So if I want to list the first element in the list, well, that gave me 2. So that's actually the second element in the list. The reason is Python, like most programming languages, and I think I mentioned this, when you are referring to a list, or pretty much when you're counting anything in Python, the first number is 0. So counting in Python, as well as many other programming languages, starts with 0. So to refer to the first element of the list, I type my list name. That's the variable L. I type square brackets. And I type square brackets. And then I refer to the index, or the number of elements in there. And so the first element in my list is referenced by 0. The second element is referenced by 1. And the third one, of course, number 2, is referenced by the third one is referenced by the number 2, and as I created my list up here at the beginning, you can see 5 is the third element in the list. So I can also iterate through my list. Did we talk about for loops? Is for, and we often talk about the index, and that's why you'll often see a variable called I. I means index, and it's an abbreviation. It's just a convention used long before Python was invented. I think it's probably a convention from the C programming language. Now, in many programming languages, you might see, for instance, in C, you would have I equals 0, I is less than 10, and then I plus plus. And then you would write your loop beneath that in C-style programming languages. Python's a little bit different, right? So it's actually for I in range, and then we do 1 to 10. And then we can print all those things. And then there's another kind of loop, which is called the while loop. And we'll cover that in just a second as well. We'll go back to our reading view. Loops. So let's make a for loop. And I'm actually going to do a for loop on our list. So I hop in here. So I will say for I in L. L being that list I had before. And you can see that L in IPython, I can just type any variable, right? And if I just type name, enter, it's going to output Aaron. L outputs the contents of my list, 1, 2, 5. So Now that that's clear, for I in list or in L. I can't use list as the name because it would overwrite the keyword list. Well, not the keyword, but the function list. I can just print I. And that will, so it prints 3 different times, so it prints on different lines. It prints 1, 2, and 5. I can make another list, and I'll make a list like we saw in the introduction, right? I can make a list of knights in Monty Python and the Holy Grail. So I've got Lancelot, Galahad, Bedivere, and Sir Robin, the not quite so brave. And I can do for knight in knights. All right, let's try this again. For knight in, oh, you can see I got a typo here. For knight in Knigits. All right. Notice the for loop starts with for, and then we have the variable that's getting assigned, and then we have in, the keyword in. So for and in are both keywords here. And knights, I don't need a parentheses here. It gives me that list of knights that we have. And then for each knight in that list, we will print out that knight. And with IPython, I have to have it after my last statement. That's where I got messed up there. And it will run, and it prints 1 line each for Lancelot, Galahad, Bedivere, and Robin. There are some other cool things you can do. With lists, you can actually do a slice. So I can say for knights 1 through 3, print the knight. And so then it just presents Galahad and Bedivere. So this is called a slice in the brackets, right? Inside the brackets, I could refer to a single knight, knight sub 1 or index 1. But I can also refer to the whole list like I did before. And then lastly, I can take a slice of this list. In this case, I take knight sub 1. Remember, we start with 0, so that would actually be the second knight, Galahad. And then we go to 3. Now, this is kind of tricky. You'd expect it to print Galahad and Bedivere, because if I print knights sub 3, it's going to print Robin. Any idea what's going on here? With why this range of knights 1 through 3 did not include Robin?
Because he's the weakest of the bunch.
Kind of. Actually, it doesn't matter. I can actually add another knight. With append, for instance, I can append a knight. And help me out. Who's another knight from Monty Python and Holy Grail? I suppose we could just include Arthur, although he's their king. I guess he's also a knight. So append is a function that exists on a list, right? And I can actually see that. I can type list and question mark. Again, this is an IPython only that question mark works, and it will give me some documentation. So I'm getting documentation on the list function, or this inbuilt function. So it shows me this list can take either an iterable and then comma a slash. I'm not sure what that means. So it says it's a built-in mutable sequence. It's a sequence, it's a list, it's a collection, it's an array, and it's mutable. Mutable means changeable. That'll be important later when we cover tuples. It says if no argument is given, the constructor creates a new empty list. That's when I did this. I did L equals bracket, bracket. That creates a new empty list. And we saw that when I did a type of L, and it said list. The argument must be an iterable if specified. And an iterable is a list or some other type like that, a list or a dictionary or a tuple or a set. It can convert between those, just like we can do a string. We'll just call it S equals K for knight, Knigget. And then we can print S, and the type of S is a string. And then we can do S equals string of 1, and we can print S. and it's 1, and the type of S is a string. Although if I did S equals 1, the type of S would be int. All right, back to lists. Our list of nights. Where were we at? Oh, we're making a loop of our list. So the answer to this is the second variable in a slice, or the second value, I should say, in a slice is exclusive. So this means including index 1 up to, but not including index 3. And I think I mentioned this at the very end of last week, right? In algebra, if you can remember that far back, you have an inclusive set, and this would actually include all of 1 through 3. And then you have an exclusive set. I may have it backwards. And this would include 1, but not include 3. Or maybe it's the other way around. Anyway, so the end value in a list is exclusive. So that's why we see that here. Even though Robin might be the weakest of the nights, if we go 1 to 4, we print nights. It'll print Robin, but if we print all of our nights, we should see also Arthur, King Arthur. I guess there's Gawain. I forgot about him. Is it Galahad? Galahad the Just? Anyway, so we've got our list of nights. Let's go on and talk about something else. Oh, we've got someone else joining. Welcome. So we're talking about lists, and we're talking about loops. So we've got a for loop. Let me go back to talk about another way we can iterate through a list in a loop, right? So let me clear my screen here. We've got our nights. We can replace a night, so I can do nights. And if I want to replace Arthur, yep, that's nights sub 4 is Arthur. I can reassign that value, and I can make it Gawain. And then you can see if I print my whole list of nights, I'll actually go through and oh yeah, next time through. So for I in range of length of nights. So this is a really interesting thing. I don't know if I've introduced range to you. Range is a function that builds an iterable, something that can be iterated or gone over in order, 1, 2, 3, 4, and so on. And then I can print the night, just like I've done before. I forgot my closed parentheses around range. I didn't forget it. I just typed the wrong key. So what it's doing here is it's going to, let's look at length of night. 5. Now remember, this is -1, so night sub 4 would be Gawain. So why is it printing Robin? I'm just going to pretend I don't know what that is.
Is it not print I?
Oh,
Print
thank you. Yes, so I is the variable I have, not.
You want to print the elements of the list, right? So,
yes, exactly. Thank you. And it's all right. So I want to print I here, and then we get 0, 1, 2, 3, 4. The reason I printed that is because the last night we set up night is Robin. When we did night equals Robin at the very beginning. All right, that was baffling me.
but again, this is not what we want, right? We want to print.
Yeah, we want to print each night.
Elements of the list. So
here's how we would do that. We would print nights sub I.
Okay.
Good. Yeah, exactly. So, right, if we do that, it'll work because, well, we can print nights sub 0,
Mm-hmm.
and we can print night sub 1, and so on up to the last one. So that I should have introduced the most basic for I in range 1 to 10, right? And then if we print I. Now range, this range function creates this, it's like creating a list. And it prints 1, 2, 3, 4, 5, 6, 7, 8, 9, excluding 10. Now, what I wanted to show is the whole reason, not the whole reason, the main reason that I know of that range is exclusive of the last number, right? If I do length of nights, it's going to give me 5 because I have 5 nights. But our list is night, right? Remember, -1, we start with 0. Night sub 0, oops, nights sub 0, sub 1, 2, 3, 4, and then if we do night sub 5, we get an error. List index out of range because, well, because our list of nights starting at 0, 0, 1, 2, 3, 4, there's no 5. So that's why range is exclusive of the last number, simply because this is a very common scenario if we do length of a list. All right. That's a good introduction to lists. Now let's talk about something a little bit different. I mean, now for something completely different. What am I thinking? I've got to use my Monty Python references. Dictionaries. We'll get back to while loops. So we've got our lists, we've got our dictionaries. A dictionary is a data structure like a night. It's been one of those days, guys. You're going to have to suffer with me, or you can leave. A dictionary is like a list in that it is a sequence of items. You can see a dictionary, unlike a list, uses curly braces instead of square brackets. So I'm assigning a variable D equals curly braces, and within that you can see I've got name, Aaron, age equals 42.99, and you can see each of these has a colon, and it's pretty obvious looking at it what's happening. It's creating a variable with the key of name and the value of Aaron, with the key of age and the value of 42.99, and another variable with a key of 5, an integer here, and the value is 3, sir. And so let's go ahead and take a look at a dictionary, right? Let's create a dictionary and call it favorite colors. You can see I'm using the underscore as kind of a space here. This is also a common convention in Python that I want to have 2 words in my variable name, but well, if I put a space, Python's not going to understand. So I use that underscore character to make it both readable. I could just as easily do favorite colors like that, or I could do favorite colors with a capital C. That's called camel case. But in Python, we usually do underscores. All right, so favorite colors, I can put those curly brackets, which are just shift over the square brackets, and I can do type of favorite colors. And it's a dict or dictionary. And to think of a dictionary, when you're reading a dictionary, there's a bunch of words, right? You can look up the word coward, and it'll have a picture of Sir Robin next to it, and it'll have, a definition of whatever. So that's a dictionary. It has a set of keys and a set of values that go along with them. So to go with our favorite colors, we can create a list of knights, right? I'll just do Lancelot. I think his favorite color was blue, right? Anyone remember? And then we can do Robin.
I think that
And his favorite color, of course, is yellow. Because yellow is symbolic of cowardice. And so we've still got a dictionary here. And we can now refer to that. So we can get the favorite color of Lancelot. Now notice it has the same square brackets to refer to an index. But in this case, the index is the string Lancelot. And it returns blue as his favorite color. For Robin, it will return yellow. And so on. I could add to my favorite colors. And I can add to that, there isn't an append in favorite colors. Again, this is IPython. So I can do a dot and then hit the tab. So dot tab. In IPython, this interactive shell will give me a drop down of things I can do. I can clear my dictionary. I can copy. I can get a particular value. So I can get Lancelot. And that's the same thing as using this bracket here, except it's a function called get, and it returns blue. And there are some other features that we won't get into. We can get a list of the keys. We'll do that. And the keys here are Lancelot, the first one, comma, Robin, the second one. We can get a list of the values, which would be blue and yellow. And you can see it returns this type dict keys or dict values. That's for iterating through it. And those are probably the most useful ones. But what I wanted to show you is there isn't a append, right? In a list of knights, I did list.append, and I added Gawain. But there's no equivalent in dictionary. The way we would do that is we actually just set a key as if we're referencing the key, like I did favorite colors Robin. So I can add favorite colors Galahad. We'll give him a favorite color of green. And again, I'm so inconsistent with quotes, single quotes, double quotes in Python. It doesn't matter too much. And now I can look at my list of favorite colors. And it shows Lancelot has blue. That's what that colon is showing. Robin has yellow. And Galahad has green as his favorite color. I can also remove someone. And if you saw favorite colors dot pop, will pop an item from the list. I didn't cover that in list. So a list is like a stack, right? You push items down onto a stack. The first one goes in. The second one goes on top of it. The third one goes next. So if you pop something off the list, that's where that comes from, because it's a stack. That's a computer sciencey term that sounds fancy. We added some variables to the stack. Well, it's literally as simple as that. It's a stack of variables. So we can pop an item from the list. We'll look at the message here. So it says pop, remove key optionally with the val or D. I don't know what D means, but it will return the value. So it removes an item and returns the value. So this is popping, right? So my last one on the list is Galahad. So if I do favorite colors pop, I need to, unlike a list, right? So I can do knights.pop, and it returns Gawain. And if you see, my knights now no longer has Gawain in the list. But for favorite colors, you actually have, it's not a sequential list, so I have to pop off the particular knight. So Galahad. And it returns his favorite color because it's a stack. But my favorite colors.
Excuse me, are we talking about list or are we talking about dictionary now?
We're talking about dictionaries now. I'm pointing out the comparison and the difference between the pop function on the list and the pop function on a dictionary.
Okay. Because I saw all of a sudden knights.pop gave us.
Yeah, and I wanted to compare that. I did go over pop on lists. And sorry for the confusion. I was kind of switching context without a warning. as often happens in Monty Python and the Holy Grail, I might add. So we've got our dictionary of favorite colors still, and we can do it in the same way, right? I can also pop what is it? Pop item, yeah, pop item, and then I specify a key. And what will this do? It will return. It will return the item from the list, and it will return both the key Robin and the value yellow. So now I need to add some more knights to my favorite colors. We'll add Galahad green and Robin yellow back in here. I think I'm inconsistent with my uppercase, lowercase too. I just want to have more items for demonstration. So, all right. Oh, good. They're all lowercase in this one. I could show you how to do a list comprehension, or actually a dictionary comprehension. We're not going to cover list or dictionary comprehensions today. That's a little bit more advanced than we want to do. But so a dictionary it's like a list, but it's a list of paired values, a key, which you can think of as the name of a variable, and a value. You can think of that as the value. So it's useful in many ways. What I want to cover next is we covered get. We covered setting a value in the dictionary. Oh, we didn't cover that, right? So I can do favorite colors dot get for Galahad. Right, we did that. We get green. There's no corresponding set function, but we can change Galahad's favorite color, just like we assigned him initially. We can set his favorite color to red. And so now we have Galahad's favorite color is red. So a couple of things to note about dictionaries is you can't have two keys that are the same in a dictionary, but it won't throw an error. It will just overwrite the previous value associated with that key. That's a common source of errors, especially if you can imagine you're creating a dictionary to store a bunch of information, and for some reason you have a duplicate key that you weren't aware was a duplicate, and you end up overwriting something that existed previously. Something very important to watch out for in Python. But that's typical behavior. Other languages have similar functionality to a dictionary in Python. Some languages will call it a hash or an associative array. I think that's PHP calls it associative array. In Java, it's called a hash map. In JavaScript, they just call it an object. An object in JavaScript is literally looks exactly the same as this, with some caveats. But this particular one is a valid object in JavaScript. And any object in JavaScript, it consists of a key and one or more values. And you can have nested objects just like you can have nested dictionaries. And you can have a list of dictionaries or a dictionary of lists and so forth. Any questions or comments on dictionaries before we go a little further? Oh, was there a question there?
No, I'm good.
All right. So I'm going to talk really briefly about two data structures that are less common, but are also useful in some cases. One is a tuple. Now, you may have noticed when we call get, wait, not get, when we call pop item on a dictionary, it's going to remove the last item, and it returns Robin yellow in single parentheses. That's a tuple. I'm going to pop item again, right? So I can get length of my dictionary, favorite colors, and the length is now only 2 because there are only 2 items in that. If I call pop item again on favorite colors, it's going to return something. I want to save this as a variable though, so I'm going to call this, just going to call it night, knigget. Now, instead of printing out that value, I still have that value there. It's in night. And if I do type of night, So I call the type function on my night variable, and it returns tuple. Let's read a bit about tuple. So in IPython, I put the question mark, and it says an int signature tuple iterable. If you remember list, it said it's list is a built-in mutable sequence, but a tuple is a built-in. Sally sells seashells by the seashore. A built-in immutable sequence. Do you guys know the difference between mutable and immutable? It's a common term in programming, but not very common outside of it. Essentially, mutable means changeable, like it can mutate. Immutable means not changeable. It can't mutate. So if I were to try to take night, so if I got night sub 1, that's his favorite color, and I try to change this back to, what was it, green? I get an error. Tuple object does not support item assessment. So a tuple is like a list in that it's an ordered sequence of items, and I can even do for, and I can print I, and this should print Galahad and red, I believe. Oh nope, type object is for I and night. There we go, and it prints the two items. Galahad is the first item, and red is the second item. We can refer to them by the same instance, right? Night sub 0 is the first one, which was the name in our dictionary. Oops, night sub 1. Oh, IPython wants to fight me. And the color. So what's the value of that? Well, a tuple is not changeable, which sometimes you want a value that can be changed, and it's also more efficient. Think of all the things that Python needs to know behind the scenes to insert a value into a list, to either append it to the end or to find a particular item in the list and replace it. Those are extra features that come with some cost. A tuple doesn't have that cost, so it makes it more efficient than a list. That's all we need to know about a tuple, is it's like a list, but you can't change any of the values in a tuple. All right, now let's talk about sets. You might also know sets from your days in algebra. I do not, because that was a long time ago. So a set is like a list as well, and it's also kind of like a dictionary, which is why when I type of S, oh wait, that's a dictionary. But I'm going to change it. A set is like a dictionary in that no two keys can be the same, or rather, no two values. A set is like a list in that it only has a set of values. So I can have a set of 1, 2, 3, and that's fine. And if I do the type of S, it's now a set instead of an empty dictionary. That's just one of the quirks of Python. A set in a dictionary. If I wanted to assign an empty set, I would call the set function or the set constructor, and the type of S is set now. Just like I could do D equals dict, and the type of D is a dictionary, or L equals list. This is the list function that constructs a list, and the type of list is L, or the type of L is list. And also the same thing with tuples. Type of T is tuple. But sets, unlike lists, dictionaries, and tuples, don't have this shorthand function for creating it, right? L equals square brackets, or dictionary equals curly brackets, or tuple equals parentheses. Small price to pay. Now a set, in set theory or in algebra, right? No two items in a set can be the same. So if I try to make a set, square brackets here, if I do 1, 2, 4, 3, 4, or okay, let's stick with 4. 1, 2, 4, 3, 4. Wait a minute. I thought it was going to throw an error. It didn't, and it ignored the duplicate 4. So this, and that makes sense, right? the set of two lists is the difference between them. So if I did list 1 equals 1, 2, 5, and the set of list 2 is someone who counts a little bit better than King Arthur. 1, 2, 3, and someone who can type better than me. And if I do a set of list 1 and list 2, is it join? I need to learn my syntax. I hardly ever use sets. I guess intersection, union. I can do a union of these two lists. And normally a union, if you're thinking, again, algebraically, it's all of everything. So it would have everything in set 1, or everything in list 1 and everything in list 2. Also in SQL or in relational algebra, that's a union. But now I'm confused. What's L1? 1, 2, 5. L2? 1, 2, 3. I'm not. Now I'm in mysterious territory. Is this going to add everything up to 9?
Is it not concatenation plus L1
Uh,
plus L2? No.
I'm wondering where that 4 came from. I actually don't know. There's no 4 in either one. So maybe I wanted to do S. Oh, I know why. Because I already did S equals 1, 2, 3, 4, 3. But when I did the union, never underestimate your own stupidity is a rule I try to live by. But sometimes I just do a typo instead. And okay, forget it. I don't know what's going on. Let's try intersection. Oh, the intersection of L1 and L2 is 1 and 2. They're together. So I'm going to make S an empty set. Oops. So the problem is I created S. So S equals set. Because I did S equals like this, and it created a dictionary. So now I do S.union. Here we go. 1, 2, 3, 5. Wait.
That's right, right?
Yeah. Oh.
One,
Yes.
2, 3, 4.
So because 1 and 2 are the duplicates, it didn't copy them both over. Okay. Forget about sets. Sets stink. I just don't know my math. All right. So that's sets. Sets are mutable, changeable. They are not ordered, although I can refer to S sub 1. Oh, no, I can't refer to S sub 1. But they are unique items. That's the key to sets, that they are unique. I think there's something like a mutable set. Is that called a deck? I don't know. Data structures, fun stuff. Okay, let's talk about functions, and then I'm going to give you an assignment. I don't think we're going to get to PyTest beyond the basics. A function is a group of code that exists together. It starts with the def keyword. It has a function name, and then it has 0 or more parameters. That's what's in the parentheses here. You might say, well, the parentheses are used for a tuple. That's an interesting point. It's true, and it's used differently, but we also are essentially creating a immutable list of the arguments to pass in, although each variable in a function that's passed as an argument can be changed, but it doesn't change the external items. And then it ends in a colon. We've seen a colon used in an if statement, in a for loop, and a function definition. That's what def stands for, define function, also has a colon. Pretty much anytime you have a colon, it's creating a block in Python, and you need to indent that block and your indentation needs to be consistent. So let's take a little bit of time to look at a function. So, right, so this is from Monty Python, right? So we want to ask a question of a knight. Well, let's just start with a function called ask to make the simplest possible function, right? So we can do answer equals input. If you remember from the beginning, we did hello, what's your name? And then we printed hello, your name. So we'll do the same thing. What is your name? And then we'll just print the answer. All right. Now, that's how we define a function. That's a pretty simple function. I can now reference this function just like I can reference a variable anywhere else. So I can call ask with the parentheses, without parameters in this case, because there are no parameters, calls my function and executes this code we see above. Input, what is your name? Robin, and it prints the answer, Robin. So that's really like the not really the simplest, I guess the simplest possible function would be print hello. But we can reuse this in multiple places, and I'm going to show you how to do that, hopefully with a while loop if we get to that in time. Okay, I want to do something else with this. Is I don't want to just print your name. I want to ask a question, and I'll do answer equals input, what is your name? But instead of printing the answer, I'm going to return. Return is a keyword. I'm going to return my answer as a keyword, or I mean as a variable. So now I've redefined my ask function. And we can actually look at the type of ask because a function is also a variable and the type of ask is function. You can pass a function to another function. You can generate a function within a function and return that function. And now we're talking about something called higher order functions that I'm not going to get into. And that's very dizzying to think about. All right, so we can now call ask our ask function. Call it with the parentheses. What is your name? Robin. And it says output Robin, but I don't know if I told you guys this. Whenever you have a value that's set and not defined in a variable, Python saves the last unsaved variable, or the last variable saved or not, in a default variable named underscore. And so underscore is Robin. So I could actually do this. I could do name equals ask. What is your name? I'll change it to Aaron this time. And then I can print name. I can welcome Saad. I can print hello name. And it says hello Aaron. I can do name equals ask again, and I can say my name is Robin. And then I print hello name, hello Robin. So ask is returning my answer, and you can see this is another IPython trick. Two parentheses will give you the documentation. In this case, I don't have any documentation on my function, but it will also print the source of my function. So going back up to this again, I've got my ask function. It inputs, prints out what is your name, waits for me to enter, and then enter some text and press the enter key, assigns what I typed to the variable answer, and returns that variable answer. I'm going to do another thing. I'm going to pass an argument to this. So I'm going to ask a knight a question. And so in this case, we're going to change this. We want to print hello name or hello knight. And instead we'll ask, what is your quest? And we'll return the answer. We'll actually just call this quest. All right, so now we can ask a question. And we need to pass in the knight's name, so we're gonna pass it. We'll pass in Lancelot. We've been picking on Robin for a while, so we're gonna ask Lancelot a question. Hello, Lancelot. What is your question to seek the Holy Grail? And it outputs to seek the Holy Grail. And if I want to capture that value, I can do quest equals ask Lancelot. What is your quest? If he has a separate quest. And now we can print quest. And it's the value that we return from that ask function. That's not all you need to know about functions, but that's a good start. A function, to review, is a block of code that is defined. It can have one or more variables that you pass in. It can perform one or more statements, and it can optionally return a value. We can return whatever we want. It doesn't have to be that. We can return anything. So if I now ask Lancelot, what is your quest? And then I print my quest. It says quack, because quack is what I returned. And I guess if he floats, then he's a witch, right? So that's a basic introduction to functions, as well as these data structures, which are iterable, which means you can loop through them, except for set, lists, dictionaries, and tuples. Remember, a list is a sequence. A dictionary is a key value sequence like this. I've got a typo in here, maybe. Oh, I missed my equals sign. And a tuple is like a list, but I can't change the value of it because a tuple is immutable. And then lastly, a set is like a list with no two items the same. So here's the assignment. I want you to create a database. That sounds like a complex task. What I want you to do is to create a database of people. Let me write this out. Create a database of people, if I can spell people, with including their name, age, and favorite color. And this is kind of tricky. And then we want to be able to retrieve different people from the database. I want to, for instance, get Robin's favorite color. Now, I don't mean a database like SQL Server or MySQL or something like that. I just want you to use a data structure. Any of these data structures or any combination of these data structures. But what I want you to do is be able to retrieve the first person in our database or the last person. To be able to tell me the age or the favorite color of a particular person. And here's the stretch. To be able to get any people who may have the same age or favorite color, right? So get a person by index, so first person. Tell me a person's age or favorite color given their name. And if I have your emails, I can send you this task of what to do. So we want to create a data structure, not really a database, that contains a group of people, their ages, their favorite colors, and be able to retrieve any person by their name, by their position in that data structure, and get individual attributes for a person based on their name. Does that sound like too much of a challenge?
Yeah, looks like
It looks like too much of a challenge?
we'll explore.
All right. You're also, it's an open book test. You can use the whole internet, and I will also send some hints. I'll post this challenge or this assignment online. So on oneshore.com is my website, and help me out. It's just oneshore/workshops, right? Even though it's not linked. Oh, I think you did add the link on the home.
Correct.
Okay. So workshops goes to register, so you can get your email sent there. But we got all your emails here. Okay, it's on the homepage. You've got it already on there, right?
Mm-hmm.
Okay.
Scroll down a little bit. Yep.
There we go.
Keep going.
Okay, view workshop library. All right. So here you can see each recording. Okay, here we are. Getting started with Python for test automation. You'll see each recording, and we'll also have a link to a page describing a summary of what we covered, in plainer English than I can speak impromptu, and we'll put the assignment on there. Any questions or comments at the end?
Aaron, I have one complaint.
Great, only one.
Do my Monty Python quote.
Too
Are you
much?
suggesting coconuts migrate?
We'll get to that later.
Coconuts migrate. That's my.
All right. Well, everybody have a good weekend. We'll see you next week then.
You too.